Hey team, I wanted to give you some insights into the water valve challenge that I gave you in the previous class. And I've seen some of your work, I've seen what some of you have built as controllers. I want to show the general ideas that I've seen so far so that you have an idea if you're struggling with this, or even if you want to know what your classmates are doing. I've put together this video to show you some of the approaches. So the first thing I want to show you is this is a JavaScript simulation that does essentially the same thing as that water valve controller that a lot of you have been working on. The difference here is that I have a little slider at the bottom that I can move around that controls the control signal, and you can see the set point, which right now is set to 4.5, just as it is in your simulation. I wanted to show how a human, how a person might do this, because it's not that hard to then program a controller to do the same thing. If I was just trying to adjust the output, I would increase it, decrease it, until it gets close enough to the value that I'm trying to reach. I am using very quickly a feedback loop in my head where I say, right now, where is the water valve? It's obviously below where I want it to be, so I need to increase it a certain amount. Did I do enough of an increase? Clearly not, so I can increase a little more and a little more. And now that I see it's close enough, now I just sort of leave it there. This approach we might consider to be kind of a candidate for on-off control. But the way we implement it in code is different from what we might do for any of the other tasks. And that's specifically because we don't have a way of directly setting the output to be fully on or fully off in this control problem. Take this and slide it all the way to the bottom, and that's obviously too much. Turn it completely off, and that's obviously too little. And we want to do better than those two extremes. So I've implemented some on-off control to show you how I would do what you just saw in terms of me as a person trying to solve this problem. And here's how I did it. I simply said there's a signal that you're sending, and if the current value is less than the set point, I'm going to take that signal and I'm going to increase it a little bit. And I defined a variable control increment up here to just say, let's make it 3. If the current signal is, or the current value is above the set point, I'm going to decrease it by that control increment. Make that an else if, and then let's put in an else and just say slider.value current signal. So that means that if that's not the case, just hold the signal that it's on. Let me add current value is greater than set point. There, now I think that's happy. So let's run the code and see what that does. And keep your eye on the slider to see how it's responding. So we can see that control signal is increasing. Once it's within the range, it's kind of holding it and leaving it where it is. You might see a place here for tolerance. I could put in a tolerance and then the signal just stays there. The signal is noisy, it's bouncing up and down, and so it might be okay to kind of have those going left and right. But this is good enough, I think, for our control problem. Another thing that a couple of you have shown me is that you've implemented a proportional integral controller. I want to show you some things about that here. I've updated the code now to be a proportional controller. You can see I'm calculating in this line the error as being the set point minus current value, and then I'm making current signal proportional to that error. And I've added a k value of 5 up here. When we run the code, we can see that the sensor reading is below where we want it to be. Normally when we do that, when we don't see the kind of behavior we want, we increase that k. Let's try a k value of 10 instead. And you can see that it's definitely closer to where we want it to be. And a k value of 20 is even better. But this is actually telling us very clearly that a proportional controller is not where we want to be. And the reason I know that is even by increasing this k value, there is a consistent gap between the set point, the value I want my controller to read, and the sensor values. And there's no change over time that is causing that value to get better. When we have a consistent gap between the set point and the signal, and proportional doesn't quite cut it, this is when we add in an integral term, the term that is proportional to the sum of the error. So let's add that here and see how it changes the behavior of the system. So this is what that looks like when you add that in. I am calculating a variable that is the cumulative sum of the error. I've defined that variable up here, and I am just calculating it by taking the previous sum of the error and adding in the new value of the error. And then I'm adding in that term to the proportional term. And then in this line, I'm taking that slider and I'm setting it to the value that I want it to have. Let's run the code. You can see over time that curve tends to get closer and closer and closer to the set point that we're looking for it to have. It's not fast, but the way we make it faster is we increase that value of ki. So instead of 1.5, let's try 2.5. Much quicker. Let's go all out and make it 5. And that does a pretty good job. It's pretty quick, pretty effective at getting close to that value. Let's see what happens when we change the set point. So I raised the set point from 3.5 to 4.5, and you see it does a pretty good job. Maybe 5.5. All right, so this is pretty consistent. Let's try one more test to see about low values. And our controller is now able to do a great job of maintaining that set point value that we want it to have. So this is pretty neat that with only a couple of lines of code, we're able to get this system to track to the set point that we want pretty easily. And this is the power of a good control algorithm. It's reliable, can react to a range of set points, and only requires a little bit of tweaking to get it to work exactly the way we want. That's going to do it for the water valve controller. Thanks for watching.